Symbian versus Android. This is the second part of our video, Symbian versus Android. In the first part of our video we have explained how mobile technology developed time to time and why mobile operating systems came into drama, and brief history about Symbian and Android operating systems and features and capabilities of them. In this video we are considering about system architecture of Symbian and Android and the difference of these two operating systems, and compare the latest smartphones of Symbian and Android. First of all, let's consider about main differences of Symbian and Android. If we consider about Symbian, it was a proprietary operating system for mobile devices until recently. Under Android's huge challenge and losing market ground, Nokia bought all the Symbian outstanding shares, and created Symbian Foundation and declared it open source. The main platforms for Symbian include S60 and UIQ. UIQ was closed down and all people got laid off shortly after the creation of Symbian Foundation. As to how appealing open source Symbian to developers is yet to be seen. S60 series are no doubt the leader in number of installed base today. However, Symbian's market share, especially in the smartphone area, is getting smaller and smaller largely due to iPhone. The main language used for Symbian programming is D.M.B.M.B and C++. C++ API provides lower-level device access than D.M.B.M.B. However, their C++ implementation was unnecessarily complex and error-prone. Their paradigm was not suitable for the needs of modern mobile computing. It required a great effort to deliver something comparable to Android and iPhone. But now Nokia has emerged with a new smartphone, Nokia N8, using the latest Symbian 3 operating system which challenges to Android. Then the Android is an open-source mobile operating system platform that's running on top of Linux kernel. It uses a non-standard Java virtual machine called Dalvik, specialized to handle mobile device processes. The main programming language used for Android is Java, with many library from J2SE and third-party open-source projects, such as Apache Commons, SQLite, WebKit and etc. Android is tightly integrated with Google's cloud services, such as Gmail, Calendar, Contacts, Gtalk and etc. This positions Google at a very good edge to monetize mobile ad revenues. Android's open-source nature enables manufacturers to design and customize the platform to their own likings, so fragmentation is a concern here. However, the core Android operating system provides more than enough features for current mobile needs of devices. As it evolves, it might include more standardized features, and the operating system platform can only become better and better. Those are the main differences of Symbian and Android. Now let's move on to the next topic, architecture of Symbian operating system. Let's start from the kernel architecture. Today's Symbian operating system might be referred to as EKR2 as well, which means Epoch Kernel Architecture 2. EKR2 is the second iteration of Symbian 32-bit kernel architecture, and this in turn follows 8-bit and 16-bit kernels designed in the 1980s for some personal organizers and P.B.S. As can be seen in Figure 1, the architecture is modular, where operating system functionalities are provided in separate building blocks, and not in one monolithic unit. Symbian operating system is single-user. Indeed, there is no concept of multiple logins to a Symbian operating system smartphone, unlike Windows, Unix or traditional mainframe operating systems. In addition, it is multitasking, being able to switch CPU time between multiple threads, giving the user of the mobile phone the impression that multiple applications are running at the same time. Moreover, it is a preemptively multitasking operating system because it does not rely on one thread to relinquish CPU time to another, but reschedules threads per force, from a timer tick. It is worth mentioning that Symbian operating system is a priority-based multitasking operating system with priority inheritance. The operating system allocates CPU time based on a thread's priority and minimizes the delays to a high-priority thread when a low-priority thread holds a mutex it needs. Furthermore, Symbian operating system is real-time based and its services are bounded, that is, it completes them in a known amount of time. The core operating system is formed by a microkernel built as a personality layer on top of a real-time nanokernel. This block is responsible for primitives such as fast synchronization, timers, initial interrupts dispatching, and thread scheduling. The Symbian kernel might be referred to as the combination of the nanokernel and the microkernel. Interestingly, the nanokernel has been designed to provide just enough functionality to run both the telephone, GSM GPRS UMTS, signaling stack, already written for real-time operating system platforms such as Nucleus and Muatron, and the personal information management, PIM, part on a single processor. This approach provides considerable cost savings over the usual two-processor solution. Generally speaking, Symbian operating system is intended to run on open, small, battery-powered portable computers, which are modern advanced state-of-the-art mobile phones. Besides this, it is designed for 32-bit CPUs, running at low speeds, usually less than 400 MHz, relative to those in desktop or workstations. Today's Symbian operating systems are based on X-Scale, ARM9 and ARM11 based CPUs, while older devices are powered by the ARM7 family of CPUs. Symbian layered architecture. The simplest architectural view of Symbian OS is the layered view given by the Symbian OS system model, the kernel services and hardware interface layer. The lowest layer of Symbian OS, the kernel services and hardware interface layer, contains the operating system kernel itself, and the supporting components which abstract the interfaces to the underlying hardware, including logical and physical device drivers and variant support, which implements prepackaged support for the standard, supported platforms, including the emulator and reference hardware boards. The next level up is the base services layer. This is the foundational layer of Symbian OS. The base services layer provides the lowest level of user-side services. In particular, the base services layer includes the file server and the user library. The microkernel architecture of Symbian OS places them outside the kernel in user space. This is in contrast to monolithic system architectures, such as both Linux and Microsoft Windows, in which file system services and user library equivalents are provided as kernel services. Other important system frameworks provided by this layer include the Ecom plugin framework, which implements the standard management interface used by all Symbian OS framework plugin store, which provides the persistence model, the central repository, the database management system framework, and the cryptography library. The base services layer also includes the additional components which are needed to create a fully functioning base port without requiring any further high-level services. The text window server and the text shell. The OS services layer. The OS services layer is, in effect, the middleware layer of Symbian OS, providing the servers, frameworks, and libraries that extend the bare system below it into a complete operating system. The services are divided into 4 major blocks,